Want to know what ASP.NET Core is and what you can do with it? This course is for you. We're covering technologies like Blazor, MVC, Web API, gRPC and SignalR. And I'm showing you sample applications for each, explaining them step by step. Here are some major topics I will talk about. Server-rendered front-end applications with MVC and Razor Pages, client-rendered front-end applications with Blazor, and backend APIs with gRPC and Web API. By the end of this course, you'll be able to determine if ASP.NET Core is for you, and more importantly, what it contains and how each contained technology works. Before beginning the course, you should have a good understanding on how the web works with requests and responses, have HTML knowledge, and experience with .NET and C#. Get ready to unlock the wonderful world of ASP.NET Core with my course ASP.NET Core Big Picture at Pluralsight. Hello and welcome. I'm Roland Guit and I've created a few other courses on the ASP.NET Core topic in the past. This course is specifically about ASP.NET Core 8 and therefore is created with that version. It is useful for any version of ASP.NET Core from 6 onwards, except for the last part of the Blazor module, but I will point that out when the time comes. Should you be looking for an older version, please take a look at my author page to find the course relevant to you. You probably know a bit about ASP.NET Core already. Maybe you've seen a demo, played around with it, or maybe you've seen some documentation. But let's start at the very beginning anyway, to give you the whole big picture. Before I start, you will have to be aware of a couple of things. First, the intent of this course. It is meant as an overview of all that ASP.NET Core is, and what you can do with it. That doesn't mean this will be a course with just slides. I also show you code, so that in addition to the theory, you gain a good technical to make the right choices on what part of ASP.NET Core you could zoom into next. In terms of knowledge, we need a starting point in order to proceed. First of all, I'm assuming that you know how the web works, with HTTP, requests and responses. You should have at least a basic understanding of how HTML and CSS work, because these technologies form the basis of every ASP.NET Core application. I'm going to show you code examples. To understand them, I also need you to know what .NET is, and you should be able to read the C# programming language. If you have knowledge gaps, I would recommend watching other big picture courses around these topics first. Depending on your learning style, looking at my code examples or experimenting with them might be beneficial. If so, you can find all content in this GitHub repository. Carved Rock is a non-existent company selling outdoor equipment. I've created this webpage for them. It contains the logo, a subtitle and the phrase "Today's Specials." The HTML for this page looks like this. Of course, you can find the elements of the page here. They are styled and positioned using CSS classes that come from a popular CSS library called Bootstrap. Under the header Today's Specials, I now want to list products, and I want customers to click on them to see more details. The products for Carved Rock are in a database, so we need to build functionality to get the products out of the database and somehow render them as part of this webpage. The need for this functionality marks the difference between a website and a web application. A website is for static content. It is made up of individual HTML and CSS files that rarely change. For example, the site for a sports club that contains some info where the club is located and how to participate. As soon as we introduce functionality like getting the coming matches from an external source, or in the case of Carved Rock, getting the products from a database, we no longer call it a website, we call it a web application. To create web applications, a web application framework helps a lot. Something that gives us the building blocks to create the needed functionality and to give us a way to write our code in a structured manner so that it is maintainable and extendable. ASP.NET Core is such a web application framework created by Microsoft. It gives us the means to create front-end and back-end web applications. Maybe you're wondering now, do we absolutely need a web application framework? Well, when I want to get from A to B by car, I only have to know how to operate a car. I need not have the knowledge around how the engine works. And that's great, because now I can be focused on getting to my destination, and I don't have to think about the underlying technology. With a web application framework, in theory, you could reinvent the wheel and write all the building blocks yourself, and come up with your own way to structure the code. Apart from the time and the expertise that will take, we want to invest in creating application solutions for our organization or customer, and leave the deeper underlying technology to others. Also, using a commonly used web application framework like ASP.NET Core enables your organization to bring in other developers that already know how to work with the framework and its building blocks, making the onboarding process a lot easier while optimizing the speed of development. It's like if you buy a car of a brand and type you never drove before, you already know how to drive it. You don't have to read the manual first, because driving a car is a standardized practice. Hopefully you're convinced that using a web application framework is a good idea, but what kind of applications can be built exactly with a... Before we get into more detail, I want to make sure we are on the same page regarding front and back-end applications. A front-end application is responsible for delivering content to the browser. It has to be content the browser can understand, such as HTML, CSS and JavaScript. We learned that one of the functionalities a web application can provide is accessing data in a data store, such as a database. The front-end application could implement the logic to access the data store itself, as well as the logic around it that makes sure the data is correct, the business rules. However, most of the time, it's a good idea to keep things separated. Let the front-end worry about the user interface and create another application concerned with data and business rules. This type of application is called a backend application. And the type of backend application that provides data and applies business rules is called a web API, or in short, API. Separation will give us a more maintainable application structure, and it enables us to form separate front and backend teams. But it also enables reusability. Because it is a separate application now, other applications can consume it. This could be other front-end applications. Not just web applications, but also desktop and mobile applications. And even other back-end applications. ASP.NET Core lets you build powerful front and back-end applications. It contains 3 distinct application styles to create front ends: MVC, Razor Pages and Blazor. But that's not all. For back-end applications, there is Web API and gRPC. And finally, there's SignalR, a supporting technology that enables real-time web applications. In the coming course modules, I will introduce you to all of these. For now, it is enough to understand that ASP.NET Core can do much more than just create a web page. It is here to provide us with everything we need to create web applications. Not just the front end, but also all supporting applications. Now that we know what ASP.NET Core can do, you might ask, is ASP.NET Core a good choice? And are there alternatives? Stay tuned. ASP.NET Core is a great choice when you're in the market for web application styles, the multiple ways to create front and back-end applications. You'll soon see that no matter which one you choose, the lower level engine is the same, since they all run on the same foundational framework. This means you only have to learn the lower level anatomy once and apply that knowledge to all styles. Later on in this module, you will learn more about the anatomy. ASP.NET Core is also open source. That means it's not a black box in which you don't know what's going on. Everything is transparent. And it's good for the continuation of the product, because both Microsoft and the community are working on it. ASP.NET Core is among the best performing frameworks out there, and it runs on multiple platforms, such as Windows and Linux, giving it the widest range of hosting options possible. Modularity is also an important advantage. It has a big feature set, but almost every aspect of it is opt-in. When you don't use it, it costs nothing in terms of performance and memory. ASP.NET Core is also built on top of .NET. That means that existing .NET developers can use the complete library of classes they know and love contained in .NET in their ASP.NET Core applications, using one of the .NET programming languages where C# is the most common. There are a lot of alternatives which have one thing in common. They are not running on .NET. ASP.NET Core is the obvious choice for .NET developers. On other platforms, there is Node.js, for example, with the Express framework. On Java, there's a well-known framework called Spring. And there's Ruby on Rails and Django, just to name a few. These are all great, but of course they are for developers on the platform they're running on. The bottom line, ASP.NET Core is the web application framework for .NET developers. ASP.NET Core can be developed using the tools used to develop any .NET application. The most commonly used is Visual Studio by Microsoft. It comes in a number of editions. The downside of Visual Studio is that it only runs on Windows. There is a separately developed Mac version, however, with a slightly different development experience in which not all the features of the Windows version are available. Rider by JetBrains is an alternative to Visual Studio. It runs cross-platform on Windows, Linux and macOS, offering the same developer experience across the different platforms. Visual Studio and Rider are called IDEs, Integrated Development Environments. They have support for everything a developer needs, such as the ability to write and edit code, build it, run it, debug it, and deploy it. Visual Studio Code is also commonly used, but it is different. It focuses more on code editing, not just of the .NET languages, but almost every programming language in existence. You can still do all the other things I mentioned, but it is not integrated in the tool. And that's why Visual Studio Code is often used together with the command line interface or CLI tools .NET offers. .NET on the command line is part of the Software Development Kit or SDK of .NET, and it can do a lot of things like create a new build or running the code. Since it's the most commonly used tool among .NET developers, I will use Visual Studio during the coming code examples. In the next clip we'll see how an ASP.NET Core application starts up. To explain the commonalities across all styles of ASP.NET Core applications, I'm using the application you start out with when you start a new ASP.NET Core application with Visual Studio. Every ASP.NET Core application starts its life as a normal command line application. When the application is started, the code in program CS is executed. First, a builder object is created, which is then used to get an app object, which is finally commanded to run. Once run is executed, the command line application has turned into an ASP.NET Core application. Let's run it, and once run is executed, when the application is started, the code in program CS is executed. First, a builder object is created, which is then used to get an app object, which is finally commanded to run. Once run is executed, the command line application has turned into an ASP.NET Core application. Let's run it and see what happens. In Visual Studio, that is done by pressing the Run button, which will start a debugging session. But when using a code editor, it is also possible to open up a terminal and type .NET Run using .NET's CLI tools I mentioned earlier. The browser is opened, showing the default web page. But there is also another application running, which looks like a console application. There is some logging. It seems to listen on a URL that matches the URL in the browser. So that means that our web application contains its own web server, and browsers can talk to it directly. This built-in web server is called Kestrel. Kestrel is great because developers now don't have to be concerned about configuring a web server to run the application on while developing the application. They can simply run the project. However, when running application in production, Kestrel often doesn't suffice because it's likely that you have multiple web applications running on one server, and you want to have a single place to manage and monitor them. Or maybe scalability is needed, or other web server features Kestrel lacks. In that case, it is a possibility to put a web server in front of your application, such as IIS when you're on Windows. It is used as an example on this slide, but Nginx in Linux also works, for example. This web server will then use the .NET CLI tool to run the application and keep it running. Incoming requests to IAS will then be forwarded to Kestrel, and responses will flow from Kestrel to IAS. Developers can mimic this behavior at development time by choosing IAS Express from this dropdown, and then run the application as normal. IAS Express is the version of IAS that is used for development purposes. Dependency injection is also vital for ASP.NET Core applications. We'll see how that works next. I'm returning to the program.cs file in the application. The part just above the line that creates the app object registers services in the dependency injection container. Dependency injection is an essential part of every ASP.NET Core application. The container is a central place in which types can be registered. Each instance of the type will have a lifetime, which is determined at registration time. Once the registration is done, we can ask for an object instance anywhere in the application. The object will be automatically instantiated when we first ask for it. Builder.services is the object to do the registration on, before the actual application is started. Add Razor Pages here is an extension method that registers all needed types for the Razor Pages engine. As you might remember, Razor Pages is one of the application styles ASP.NET Core offers. You can also register your own types in a dependency injection container. You'll learn how to do that in the next module, where I will show you the first demo application. I'm discussing the rest of program.cs next. In the program.cs file, the part between the creation of the app object and running it consists of method calls on the app object that mainly start with the word use. We're setting up the internal request pipeline here. This is the part where we're opting in on the ASP.NET Core features. Once a request reaches our application through Kestrel, it is processed by a number of steps that make up the request pipeline. These steps are called middleware. All middleware in order will have the chance to do something with the request, forming the response. If you don't configure any middleware in your application would simply do nothing when it receives a request. We have to plug in middleware for routing, which maps the URL used in the browser to a part in our application. And when we want to make static files, such as images and CSS and JavaScript files available, there is middleware for that. And the same goes for authorization. So in the code you'll find use routing, use static files and use authorization, which are all extension methods that set up the middleware in the pipeline. Use routing in this case enables a general routing feature, and map Razor Pages will make sure that the URL is mapped to a corresponding Razor page. This last part is specific for the application style Razor Pages. The order in which middleware is plugged in is important, since the request data travels through the middleware in sequence. Before showing a Razor page at all, you want to do authorization, for example. There's something else to say about the static files middleware. Only files present in the www root folder can be accessed by this middleware. So all static files should be in there. All other files in the project cannot be downloaded directly. There are many more examples of built-in middleware, and there's also the possibility to create your own. You'll see the way to write the UI part of an ASP.NET Core application next. All front-end application styles have one thing in common. The way the UI, the pages or views, can be designed. It is done using Razor. Razor is basically HTML with the option to embed C# code. To show you what I mean, here's the file called error.cshtml from our Razor Pages example project. The Razor Pages application style, of course, gets its name from the Razor we're talking about in this clip. The CS_HTML extension stands for C# with HTML. In the same way VB_HTML files exist, Visual Basic with HTML. We'll soon see, however, that in Blazor, Razor files simply have the extension Razor. At first glance, this error.cshtml file seems to be just a normal HTML file. But when you look closely, there is embedded C# code. For example, there is this if statement that checks the Boolean property showRequestID on a model object. If it's true, a p-HTML element is rendered, and that shows the requestID property also from the model object. Notice that every time we begin a C# statement or expression, the @ sign is used. If we leave out the @ sign, it will just literally show model.requestID and not evaluate it as an expression. Code blocks are also possible by using the @ sign followed by curly braces. In such a block, multiple lines of code can be written ending with a semicolon. I could, for example, add a line that declares an error text variable and refer to it somewhere in my HTML markup. ASP.NET Core will make sure that the code in Razor files is processed before the browser shows it to the user. Now it's about time I told you the specifics of the different application styles. Rendered front-end applications can be created using ASP.NET Core using two different patterns. As we go through all available ways to create applications in ASP.NET Core, you'll see the code for an application created with each technology. So in the GitHub repository, you'll find the same application multiple times, created with the different application options ASP.NET Core brings. It is the carved rock application, showing all product specials. It also has the ability to add a product to the list by clicking on a link. After the new product is submitted, it will show the starting page again with the new product added. Object of the product class will be used to carry product data. But you might notice something that stands out here. There are attributes applied to the properties. They are called data annotations, and they are used by ASP.NET Core to do validation. We won't accept an empty name, for example. A name can't have more than 50 characters, and price can't be negative. We'll see how these validation rules are handled shortly. The photo file name property is used to simply point to an image present in the www root folder. In that folder is also the Bootstrap CSS framework, which I've used to lay out the pages. Product repository is a class responsible for getting the product instances. Normally, these kinds of classes will access a data store, such as a SQL database, to get the data, taking care of the conversion between what it gets from the data store and the product class. However, since accessing data stores may distract you from the goal of this course, I'm using in-memory data. Product repository has a corresponding interface. For each application, I've registered this class in the dependency injection container. This line of code means whenever there's an ask for iProduct repository, provide an instance of product repository. We'll see how we can ask for the instance soon. Notice that we're using a singleton lifetime to register the type. It means that only one instance will be created by the dependency injection container for the total running time of the application. Other options are transient, to create a new instance every time there's an ask, and scoped, to create an instance per incoming request. Notice that for an in-memory data store like this, singleton is fine. But when there are external dependencies to a database, for example, the scoped lifetime is probably a better option in order to have better concurrency support. Before I actually show you an implementation of the application, we're still missing the explanation on what server-rendered front-end applications are. I'm getting to that in the next clip. And box on this slide, I left a little bit of space between MVC and Razor Pages and Blazor. That is because Blazor is different than the other two. Blazor enables us to create client-rendered front-end applications, which is the topic for another module. With MVC and Razor Pages, we can create server-rendered front-end applications. But what is a server-rendered front-end application exactly? Here's an overview. Web applications have two important parts in play, the browser and the server. With server-rendered frontends, the server does all the heavy lifting. When the browser does a GET request to the server with the intention to fetch an HTML page, the server processes the request. Typical processing would involve getting data from the database and rendering that in a web page using Razor. When the server is done processing, it will send the response to the browser. This response will be the page in pure HTML and CSS. Now let's say there's a link in the page that the user presses. In this example, the link to the About page. This will trigger a new request to the server, which will produce new HTML output, which is again rendered by the browser. In another scenario, the current HTML displayed in the browser could be a form. Now a post request is done when the user presses the submit button in the form. The post request will be to a certain URL, but this time the form data is attached. Maybe the attachment is a new product for carved rock. The server will take the attachment and process it, add the product to the database, for example. When it's done processing, it will return HTML again as a response. This HTML page could be a list of products, showing the newly added product, or something that shows a thank you for submitting the product message. Razor Pages and MVC use different application patterns, two different ways to organize the code around the processing done on the server. Let me show you what I mean by looking at Razor Pages first. With Razor Pages, the routing mechanism of ASP.NET Core takes the URL it receives and maps it to something called a Razor page, which unsurprisingly is a page written using the Razor syntax. In this example, the /index after carvedrock.com is interpreted as a request for a page named index. The server will do everything needed to render the page and deliver the HTML to the browser. There's something special about a page called index. It is the default page, so when just the bare URL is used, Razor Pages will render the index page. Let me show you. No /index behind the URL, but the index page shows. Adding index to the URL shows the same page. We're taking a look at the location of the index page in the project. It is under a folder called Pages, and it has the extension CSHTML. Take a look at this Razor syntax. It's just a part of a complete HTML page. We're missing the outer HTML tags as well as the carved logo, for example. That's because this page uses a layout page. Under the shared folder there is an _layout.cshtml file, which contains the surrounding HTML structure. Our index page is rendered in the spot where it says add render body. By default, all pages will use this same layout page, which saves us from entering the same markup over and over again. Back to the index Razor page. The first line makes this a Razor page. And there's a model declared. The object is referred to in Razor as just model. It is used to render the products with the C# for each statement, iterating over a property on the object called product. Now where is the model coming from? When I click the little triangle in front of index.cshtml, index.cshtml.cs appears, which contains the index model class deriving from the page model base class provided by the Razor Pages framework. Index model has the products property we saw referenced just now in the index.cshtml, and there's a method onGet that fills it with all products by calling a method onProductRepository, which is injected by the dependency injection container. OnGet is called a handler method. It will be executed when the page receives a GET request. And there's another interesting thing in the Razor I want to show you. There's an anchor tag that has an attribute called ASP-page. That's not a standard HTML attribute. This is an example of a tag helper. This attribute is processed by ASP.NET Core when it renders the page, just like the embedded C#. ASP-page takes the name of a page and turns it into a URL, which is then rendered in the href attribute of the anchor tag. So this will generate a link to the create page. Let's take a look at the create page now. It contains an HTML form that generates a post request. There's nothing special about the form itself except for the fact that tag helpers are used. ASP validation summary will display a list of all validation errors as soon as they are present. And ASP4, present on both the labels and the inputs, references a property in the model called newProduct. Here's the model with the newProduct property. It is decorated with a bind property attribute. This means as soon as the form is posted, this object will be automatically filled with the posted values. This is called data binding, and here's how it works. The input elements with the ASP4 tag helpers in the Razor I showed you will look like this when the HTML is sent to the browser. The name of the input is newProduct.name and newProduct.price, and both inputs have a value. When the form is posted, ASP.NET Core will now try to bind the values to an object with the bind property attribute that has the name specified in the input's name before the dot. In this case, we have a match, and after that it will look for a property on the object that is specified after the dot. Since the product class has a name and the price property, the property values in the object will automatically get their values from the posted data. Returning to the model class, it also has a handler method, but this time the method will be triggered when a post request is received when the form is posted. In it, we just tell the product repository to add new product. Nothing more is needed because new product will now be filled with the posted data automatically. But there's more in onPost. Model state is valid will check if there are any validation errors. The data annotation attributes I showed you earlier will be used to validate the incoming data. When there is a validation error, in other words, the model state is not valid, we return an object that comes from a call to the page method. This is an object that implements the iActionResult interface, the return type of onPost. This object will make sure that the current page, in this case the create page, is redisplayed. But since there are now validation errors, the validation summary will show. Let me show you. Let's leave the name value empty. Because the required attribute is present on the name property of product, the model state will not be valid. The same page is displayed, but now the validation error shows. When there are no validation errors, after adding the product to the repository, a redirect to page object is returned, which also implements iActionResult. This will redirect to the page specified, in this case the index, which will display the list of products again. MVC uses the same principles as Razor Pages, but there are differences, and we'll investigate these next. MVC is an acronym for Model View Controller. Here's why it's called like that. When a request occurs, the URL is not mapped to a page. Instead, it is mapped to the method of a class. This class is called the controller, and the method is called the action. With the default routing, the URL product/index will map to a controller named product controller with an action called index. The action will then do the processing work. It will typically retrieve the data first. That data is then put into a model object which is meant for the view to consume. The view will then use the model to render the data. A post request works in the same way, and data binding is also supported. The data binding typically occurs against a parameter of the method. Program CS looks the same as with the Razor Pages project. The only difference is that we now add the types needed for controllers with views to the dependency injection container. And we call map controller route, which will define the routing rules, the way the URL is mapped to controllers. That means that the URL product/index will trigger the index action in the product controller. If there is no controller specified in the URL, it will assume the product controller has to be used. And when there's no action specified, it assumes index. When I start the project, just the domain part of the URL is used. There's no pattern for a controller or an action, so the default is used. When we add /product, the controller is mentioned, but the action is still omitted. But the default action is index. And of course we can also use /product/index. That fully matches the controller action pattern for the same result. Returning to the structure of the project. There are other folders now that correspond to the letters MVC. We have models, views and controllers. The product controller is the workhorse. The product repository is injected. And the index action returns an iAction result. First the data for the view contained in the model is fetched, and then we return an action result called view, which will instruct MVC to render the view for this action. And we pass in the model. When returning view like this, MVC will look for the view itself. It will check if there's a views folder that contains a folder with the same name as the controller class, without the controller suffix. In that folder it will look for a view with the same name as the action. Here it is. Again, it is just a partial markup for this view. And that's because MVC also features layout pages. Notice there is no line add page. That is only used for Razor Pages. The model is defined, and the model can be any type you want. Since we just need a list of products in this view, we make it an IEnumerable of product. Of course, the object passed into the call to view in the controller must match the type defined in the view. In the view, the list of products is again rendered with the for each statement. But this time we can iterate through model directly because it's an IEnumerable of product. In the final div, there's the A tag again, but this time the ASP action tag helper is used, which points to an action in the same controller. In this case, create. Let's look for a create action in the product controller. Here it is. It's just returning the view. And the view contains the form. When the form is posted, the other create action is triggered. The HTTP post attribute specifies that this action should only be executed when a post request is received. In our case, that means when the form is posted. The action accepts a product as a parameter. And here's where the data binding magic happens. Now that we know Razor Pages and MVC, let's compare them. So which one should you choose, MVC or Razor Pages? As always, it depends on your personal taste or your team preference, and on the type of project you are working on. Here are some considerations. MVC is more complex than Razor Pages. Working with 3 moving parts in MVC is harder than just working with one. In Razor Pages, model, view and controller are basically one thing. Routing is also more complex in MVC. With Razor Pages it is straightforward. A URL matches with the page. In MVC there's a routing table that maps to actions in controllers. The separation of controller, model and view could also be an advantage when there are developers just writing HTML and CSS, for example, where other developers create the logic behind it. On the other hand, changing one page, for example adding an input element, would require changing 3 separate files in MVC, which are all in separate folders. In Razor Pages, that change would be easier. Because everything is integrated in Razor Pages, reusability is more difficult. In MVC, it's easy to reuse a view, for example, by just returning it in multiple actions, even across different controllers. Hopefully, this will make choosing more easy for you. But if you can't choose, then using them together is also an option. Since they both use the same ASP.NET Core motor under the hood, they can be integrated into one project. Curious about client-rendered front-end applications? Continue on to the next module. Server front-end applications can be created using ASP.NET Core using 2 different patterns. As we go through all available ways to create applications in ASP.NET Core, you'll see the code for an application created with each technology. Client-rendered applications utilize the processing capabilities of the browser more than server-rendered applications. Blazor is the technique to use when you want to create client-rendered applications with ASP.NET Core. And there are 2 approaches to writing Blazor, using Blazor WebAssembly or Blazor Server. But first, what is a client-rendered application? When a user first accesses the URL of a client-rendered application, the request is handled by the server. The server will send back all front-end assets, such as unrendered Razor, plus the logic surrounding the user interface. That means that the browser will get all pages of the application at the same time, plus the logic to navigate through them and to populate them with data. Because it gets everything in one go, client-rendered applications fall into the category of single-page applications, or SPAs in short. As soon as everything is received, the browser logic will look at the URL and determine which page has to be displayed, after which it will render it and show it. When there's a redirect to carvesrock.com/about, for example, this redirect will be handled by the browser itself, not by a server. The internal browser router again will determine what it has to render and display that. But what if data from a data store has to be accessed? The Carved Rock index page, for example, will need the list of products. In that case, the browser will reach out to the server again. It doesn't have to get HTML or anything else that has to do with the user interface, because that is already present in the browser. It just needs the data. So the server will return just that, and the browser will apply it to the page. This server doesn't have to be the same one as where the assets came from, as long as it runs a backend application called an API. The demo application in this module doesn't use APIs yet, just the in-memory data we saw before, but that will change in the next module. We're exploring Blazor WebAssembly next. Blazor is the way to create client-rendered applications using components in ASP.NET Core. Components in Blazor are written in Razor and C#. A page is a component, but pages can also contain non-page child components that can be reused. For example, here are 2 pages. The index page uses a component to subscribe to a newsletter. The About page component also uses it in a different location on the page. One of the main advantages of using a component like this is that we only have to implement the UI and logic around, in this case, subscribing to newsletters once, and it can be reused over and over again. But let's take a little step back. Maybe you still have a burning question like, but browsers don't understand C#, so how does this work? Here's the slide again that shows the initial request to the server. The server has a user interface in the form of components written using Razor and C#. These components are sent to the browser in assemblies together with the .NET runtime that can render the components. The browser can use the runtime because it is compiled into WebAssembly. a language the browser can understand, just like JavaScript. WebAssembly, however, is a lower level language in a binary format. It is not something you write, it is something you compile your code to, just like C# code is compiled to intermediate language in .NET assemblies. Speaking of that, when the runtime executes in the browser, it will be able to process the IL in the component assembly. It will execute all code present in the components and render the razor to HTML. Here's the carved rock application done with Blazor WebAssembly. At first glance, it looks like a Razor Pages project, but there are some significant differences. The code in Program CS is different, for example. Because this code executes in the browser, we use a special WebAssembly host builder to get our builder object, after which the root component, the starting point of the application, is specified. And that's a component simply called app that comes with a template you get when you create a new WebAssembly project in Visual Studio. Each component is translated into a class in Blazor. That's why it can be referenced like this here. The app component renders in an HTML element with the ID app. But where is the HTML? It is in the www root folder. And it isn't Razor, just plain HTML, and indeed the element with the ID app is here. Another thing that stands out is the loading of a Blazor JavaScript file. This JavaScript file takes care of loading the runtime and initializing the application. Let's see what is in app.razor. Files that contain Razor have a Razor extension in Blazor. This app component contains a router component. Blazor components can be rendered using the same tag syntax we use with HTML elements. The attributes used on the component are actually properties in the class behind the component. Router is a Blazor built-in component, and the reference to the current assembly is passed in. The router component will now scan the assembly for page components with routing information that matches the current URL. If a component can be found, the route view component takes care of rendering the component with a layout page called main layout. Let's take a closer look at Blazor components. All page components are present in the Pages folder. Index has a page component that specifies a root URL. The router component will look for that when it tries to match the browser URL with the page. When I start the application, the initial URL will be at the root level. The router will match that with the index page and render it. When I go to /create, a page with the /create page directive will be rendered. Back in the index page component, there's also a code block in which the products collection is declared. Notice the for each statement that iterates over it. In the method onInitializedAsync, the products are fetched from the repository and put into the property. The repository is injected using a special inject directive. OnInitializedAsync is a handler for a lifecycle event. It is called by the Blazor runtime, in this case when the component is first rendered. Before the data is fetched, the list will be empty, and the page will also show that, very briefly. So brief in fact that I cannot show you. As soon as the products are loaded, the page will list the products. The products property is bound to the visible list of products using one-way data binding. When the property changes, the list will update automatically. The page will be re-rendered and compared with the old one. The browser will then be instructed to just update the parts of the page that were changed. This dynamic behavior is typical for single-page applications. After switching to the create page, you can see that it indeed has the /create argument after page to instruct the router. In the markup, there is something that stands out. We're using components like edit form, input text and input number to render the form instead of using the normal HTML elements for these. And that's because these components support ASP.NET Core data validation, using the data annotation attributes present in the product class. The data annotations validator component will do the actual validation, and the validation summary will display model state errors automatically. Also notice that the inputs are bound to properties of something called new product. Using this syntax, the properties are bound to the input elements in a two-way manner. That means when the property changes its value, it will be reflected in the input, but also the other way around. Edit form also calls a method createProduct when the form is submitted without validation errors. New product and the method are not in the Razor file but in a separate file that contains the code. This technique can be used to separate the code from the markup. The partial class is an addition to the class that is generated from the Razor, and there are the new product property and the createProduct method. Product repository and the built-in navigation manager are injected using the inject attribute. createProduct then adds the product to the repository and uses the navigation manager to redirect to the root URL, the list of products. Keep in mind that this won't generate a server request. Instead, the router will do its matching and show the correct page, all from within the browser. To show you how custom components work, I've created a logo component that just renders the logo using a certain height. It can be found in the Components folder. In the img HTML element, I reference a property called height. The parameter attribute indicates that it can be set by another component. In the main layout.razor file, I'm using the custom logo component, providing a value for the height property. Now that I have this separate logo component, I can use it anywhere in the application, using different heights if needed. Blazor Server is another way to create Blazor applications, without the need for WebAssembly. I'll explain in the next clip. As a Blazor Server application starts, it will establish a two-way communication connection that remains open as long as the application is used. Blazor uses another ASP.NET Core technology for this, SignalR, a framework that makes such a two-way connection possible using web techniques like WebSockets. Initially, the landing page will be rendered by the server, and the browser will get the resulting HTML. The server will be notified of all user activity, such as navigation to other pages or submitting data. It will process the user's activity and it will take care of sending new HTML over to the browser. But just the HTML that was updated. Using this technique, the user will get the same single-page application experience as with Blazor WebAssembly. The state of the application is still kept on the browser, and that's probably why this is still regarded as a client-rendered application, even though the actual rendering is done on the server. Let's take a look at the Blazor Server application. The good news is that every component I showed you in the Blazor WebAssembly application is exactly the same here, so I will not show them again. I'll just mention the differences between the projects. ProgramCS uses the builder for a server-rendered application and adds the Razor Pages classes to the dependency injection container to render the pages as well as some extras for Blazor Server. There's middleware that makes sure the SignalR hub is mapped to a URL. A SignalR hub is a class that enables the two-way connection. When a non-SingleR request comes in, such as the very first request, the _host Razor page will be rendered. The page renders the app root component using a tag helper. And from the app component onwards, the application is exactly the same as I showed you, except for the fact that the _layout.cs HTML layout page now contains the outer HTML structure and loads a JavaScript called Blazor Server.js, which will maintain the SignalR connection. If you have one more minute for this module, I'll compare Blazor WebAssembly and Server in the next clip. Hosting models. APIs aside, with Blazor WebAssembly the server has to serve some files on the initial request and it's basically done. With the server version of Blazor, the server has to do most of the work, and because the processing with WebAssembly is done in the browser on the user's machine, scaling is very cost effective. When applications have many users, scaling out with Blazor Server could get expensive. And we saw that initial loading times are longer with WebAssembly. There's no such problem with Server. Because all UI processing is done in the browser once loaded, the application can keep on functioning. For the UI to function, it is server independent. This enables scenarios where the application can be used offline. For Blazor Server, the application doesn't function without a server connection. And that's also a vulnerability. If somehow the permanent connection cannot be kept stable, it could lead to unexpected behavior. And finally, we're bound to what the server can do in WebAssembly, where in Blazor Server we can use everything we know and love in .NET. Entity Framework, for example, is used a lot in .NET to access databases. It doesn't work in WebAssembly, but it does on server. In general, however, it's a good idea to write components that work in both server and WebAssembly. And that way the switch can easily be made should the need arise. And with that in mind, what if I told you you can have the best of both worlds? Only when using .NET 8 or later, there is the possibility to create a so-called full-stack web UI. That basically means one Blazor application can use Blazor Server and WebAssembly at the same time. It involves a bit more complexity, and therefore you can still create an application that is exclusively using server or WebAssembly, as we saw earlier. Let's take a look. In Visual Studio version 17.8 and onwards, in addition to the other options already covered, there is also a Blazor web app template. In the dialog, an interactive render mode can be chosen, and either server or WebAssembly can be picked here, which will create projects exclusively using server or WebAssembly. I'll show you how this works in a minute. Both can be picked too, which is the most interesting option. Here's the demo application using that. There are two projects where one is the application running on the server and the other one the WebAssembly project running in the browser. But as we'll see shortly, we only need to start the server project to run. In the program CS of the server project, the code to start the application is different now. On the services object, add Razor components is called, and we're indicating that we want to support both server and WebAssembly components. Scrolling down, a similar configuration is done in the pipeline. Would I have chosen the server or WebAssembly option as interactive render mode, only one of these would be there. We also see that the WebAssembly project is added to the configuration, and it is also referenced. When using this different way of starting a Blazor application, every component is by default rendered as a static component, and that means as a component where no user interaction is needed. The index component we're using that produces the list of products is an example of that. It just fetches the data and renders a list. The component doesn't need user interaction, it doesn't need to be clicked on, and there are no input fields or the likes. This component lives on the server and it is rendered there and sent to the browser as HTML. And since we use the default rendering mode, because we're not specifying one, Blazor knows that that's it. There's no need to re-render it when a user interacts with it, so Blazor optimizes for that. It's a different story with the create component. That one does need user interaction, since there are input fields and a button. You can see it lives in the WebAssembly project, and it has a render mode directive set to auto. That means that when the application starts up, it will initially be handled by the server, in the same way as in a Blazor server project. But once the browser has finished loading everything that's needed for Blazor WebAssembly, like the runtime, it will automatically switch to a WebAssembly component, and therefore the browser will handle the user interaction. So this will get rid of some of the most important downsides I mentioned earlier. We can have a good way to scale, while at the same time having no delays at application startup. Now we don't have to choose a particular stack, but we can have the benefits of both. It's also possible, by the way, to set the render mode to WebAssembly specifically, or to server. But when it's set to server, the component would have to move to the server project. Remember that the render mode directive is only needed when the component needs user interaction. In all other cases, just leave render mode out, and it will be rendered as a static component, like our index component, which is faster. Since it's not recommended to write a Blazor component that directly accesses data in a database, for example, we will need another application type in ASP.NET Core to help out. In the next module, you'll learn how an API application is created with ASP.NET Core.